Okay, Assalamualaikum. Okay, welcome back. Alright, so are you ready? Have you checked your marks at the Yulen? You can already see your marks at Yulen. Hi, anyone? Alright, have you checked? Yes. Alright, so how did everybody do on the quiz? Quiz 7 and quiz 8? Okay? You're okay? Don't know. Okay, so this is if you look at your result for the quiz, chapter 7 and 8, this is how you will perform if you do not study. Okay, so this is an example. So because most of the time student will student might think that open book exam is easy. Because of the fact that it's open book, and they might think that they can discuss with their friends. Okay, so supposedly for open book exam, there should be no discussion among your friends. Okay, this is an exam, so you can only refer to your books. So this is how you will perform if you do not study at all before exam, and if you really do not actually discuss with your friends lah. Okay, so this is how you will get your marks. So I see that example let me just share the screen. Okay, this one is for for the chapter 7 electrical actuator. You will see that out of total question is 4 marks but it's total marks is 10 marks. So 4 question you get 10 marks. So only 4 student get full marks basically. And then 15 student I think answer 3 question correct. 11 student answer half of the question correct, 2 question correct, and 1 student answer 1 question correct only. Okay, so based on this one attempt, first attempt is basically like similar like for your exam later on. So you only have one attempt, and this one attempt is depending on how ready you are for the exam. So if you are not ready at all, you didn't do a revision, didn't go through the video recording that we did during classes, and didn't go through all the additional recording, additional notes via Bolton textbook, so you will get roughly these marks. Okay, so don't worry much. This will be a first attempt without any revision. Okay, means that you only refer to books, open book, online. You can go through, and if you did go through, you will actually get the answer. Okay, this one is for chapter 7. Chapter 8. Okay, about 8 students get full marks, okay, which is an increase in that compared to the chapter 7, even though chapter 7 have 4 questions, but student couldn't answer that. I think most of the chapter 7 question is theory. It's basically theory on the concept of electromagnetic. And chapter 8 is on the basic control, mostly on the, if you go through the question, is on the assignment. So you should have the answer lah, basically, because if you did the assignment and you understand the assignment, you can actually select the answer, the correct answer. So 8 students get 10 marks. I think a total 6 question there. 1 question get 5 question correct. 7 student get 4 question correct. 4 student get 3 question correct. And the rest is 11 students. So I mean, it's the highest number of students get the lowest marks here. So half of the student lah, almost half of the student. So please do some revision. Okay, take this as a example. If you do not do any revision before an exam, even though it's open book, then you will get this type of marks later on. So after class at 11, I will open again this quiz. If you haven't already get full mark, don't try the attempt again. If you didn't get full mark, then try to go through, even though the correct answer is not given, but you can estimate which one is the correct answer. You know that one question is wrong or two questions is wrong, then go through again and try to answer it. I will open the quiz 7 and 8 until this, I think not Friday. Sometimes giving too long deadlines, students do not actually do the task. So I'm going to open it until tonight, midnight, again, okay, for multiple tries. So you can try many times until this midnight. Reason why I need to put a deadline is that for you to get the marks. If there is no deadline, then student cannot see their marks. So I will put the deadline by tonight, and directly you will see your marks if you try again multiple times. If for student who didn't try again, then you should have the current marks right now. Okay, that will be on the quiz. Any question before I go to discuss on the assignment? Any question? Tak ada question. Dapat makan rendah, tak ada question. Okay, tak ada question. Okay, then try to do again the quizzes. Okay, and basically, in order to score for this subject, you need to do revision. Okay, don't skip. And if you do everything, you do a revision, go through the notes, PowerPoint, go to the recording that I did from week 1 until now, then you are capable to answer for the final exam. Okay, just a note, even though next week I will explain and bring brief again on the final exam portal, so how to answer and so on. So basically, it will use the same format as the ULearn quizzes. So you're going to have 3 parts of question. Part A will be MCQ type question, part A and part B will be MCQ type question, objective question. Part C will be subjective question. So subjective question will be almost similar format to your assignment. Okay, means that similar format is that the question is almost similar, but the case study is totally different. And there will be more than 10 case study. And so you're not going to get same question for each of the student. So take note on your case study. Do not submit another person case study. If you submit another person or another case study which is not your case study, you will totally get 0 marks. Because this had happened previously to another subject that I'm teaching, senior system, whereby students submitted the wrong set of question. So he get a different set question, but he answer a different set question. So basically, I know that the student is copying from his friend. So that student gets 0 marks. So don't do that. Answer your own set of question. So I'm going to discuss about the assignment. Okay, back again to the assignment. Even though you already submitted it, but I haven't marked it because the deadline was on Friday last week. Friday last week I was on a flight back to Malaysia, so it was 14-hour flight, and I'm still jet lagged right now, a bit sleepy and a migraine. Okay, jet lag, and I reached Malaysia on Monday afternoon. Okay, so not a good, not feeling good right now. But anyway, we will try to go through this today assignment. Okay, so the assignment, what you need to do for the assignment and also for your final exam, because the question for part C in the final exam will be almost similar format like this. So you need to understand that the topic that covering for part C will be covering all the 8 topics, chapter 1 until chapter 8. Okay, not skipping anything. Okay, for part A and part B, for the MCQ type question, is going to cover chapter 5, which is starting on pneumatic and hydraulic until chapter 8. So 5, 6, 7, 8, 4 chapters. But of course, when you have the 4 chapters, the last 4 chapters, you need to know the early chapter also, because it's also including the sensors, the signal conditioning, and also so on. Okay, so you need to know everything to answer part A, part B, and part C. But part A and B will be focusing more on the theoretical part, on the pneumatic and hydraulic, chapter 4, mechanical actuator, chapter 5, chapter 6 on the electrical actuator, and chapter 8 on the basic control. Okay, on the MCQ type question. Part C will be on the similar format like the assignment. Okay, so don't go and copy your assignment and submit that as your final exam, because the case study will be totally different. If you do that, then directly get 0 mark lah. You're not answering the question. So what you need to know, to take note is that, okay, for the assignment, you need to know all of these 3 block diagram. First one is measurement system. Okay, for measurement system, as you know that we have the sensor part, signal conditioning, and data presentation. So this you need to already embedded in your brain. Okay, when we talk about measurement system, we have the sensor, signal conditioning, and data presentation. Okay, it cannot be only one thing. Measurement system, you're talking about only sensor without any signal conditioning and data presentation. So it need to have these 3 components in order for it to make up for the measurement system. Second one is on the actuation system. So actuation system, as I mentioned in the last week briefing, okay, in a mechatronic system, a system can include, example, okay, one type of actuator, for example, electrical actuator plus mechanism, including it. So sometimes if you are building a mobile robot, okay, mobile robot, you have the motor to actually turn the wheel. So that motor is going to connect it to a mechanism or connected to some type of mechanism. Sometimes it's connected to a gear. Sometimes it's connected to a belt chain or belt drive. So you need to know what type of motion that you want for that actuation system. So actuation system, as a revision, is that you have 2 types of motion: normal motion, which is linear, and rotary. Okay, so it's depending on what type of motion that you want. If you want it to have a linear motion, but you have a limitation of rotary actuator, so you need to have a mechanism to transfer that rotation of the actuator to the linear motion. Okay, so or you can have a pneumatic actuator and plus the mechanism, or you can have a hydraulic actuator plus mechanism. Okay, and for some of the case study, there are some students who actually emailed to me and asking for the case of the case study, the problem require more than one actuator. Okay, so maybe it require electrical actuator plus pneumatic actuator. Okay, there's a reason why he want to have that, so you need to justify the reason why. So because of that, and justification normally is because of torque or force lah. Okay, if you want to have high torque or high force, then you might opt for the pneumatic and hydraulic actuator system in compared to electrical actuator. Okay? And then lastly, for a mechatronic system, since most of the time, if you have gone through the last week topic, which is chapter 8 on the basic control system, you will know that most of the system that we have right now is a control system. It's basically being controlled, everything. So example that I have shown to you in the chapter 8 video is on the Tesla, okay, the electric car, okay. And we have the example, the traffic light. Di Melaka, we have lots of traffic light with all the countdown. So they have the sensor over there, they have the signal condition, you have the data presentation because of the countdown. You know that how many seconds is left, okay, before it turns from red to green. Okay. And then the nearer example that I showed to you was the X70. Okay, X70 is almost, it's not a full electric car. Okay, electric car, if it's full electric car, means it's like Tesla. It can be, it's actually fully automated. Fully automated means that the driver can just sit there in the driver's seat without actually driving, steering the car. So they just sit there and everything is done by the ECU of the car, okay, electrical control unit of that car, to control the motion of the steering. So who's going to control the position of the steering and so on? So they are using the camera to detect the motion. Okay, detect cars, detect human, detect everything. So based on that AI, okay, artificial intelligence, then it's going to analyze what are the direction of the car and so on. Okay, that one will be on a higher level, advanced controller part. Okay, so what you're basically learning in this introduction to mechatronics is basic control, which is you have learned that there are two types, which is open loop and closed loop. Open loop basically means that the output of the mechanism is not being controlled. Whatever you give input, okay, you give a voltage to the motor, that motor will rotate non-stop. Okay, so after you cut off the input signal, then it will stop. Okay, so that's the difference with the control block diagram, is where you put a reference inside. Okay, you want to control the speed of the car. Okay, so you might want to, like for example, most of the car right now, like Honda S70, you can set the speed of the car to drive, for it to actually drive at the same speed. So it's going to drive at, for example, 120 kilometer per hour because of the speed limit. So you set it 120 kilometer per hour. So it's going to drive in that current speed. And for like example, like S70, they have the controller, the advanced controller, whereby when it detect a car in front, it's going to slow down automatically. Okay, so that's the advantage of S70 lah. They have that AI embedded in the system compared to other cars. Like I have Inspira car. They have also to control set the reference of the speed to a certain speed. But when it cannot detect car in front because there's no sensor in the front of the car to detect the object. So if you don't manually step on the brake, then you're going to crash in the front car. So the driver still need to take control of the car, just that speed is being maintained. So your leg will be rested more lah. Okay, so based on this concept, okay, so what you need to understand for assignment and for final exam is that only these three main concept is required, and I'm sure that based on that, the rest of the question you can answer. Okay, so for example, last week I shared what example case study. What case study did I show? But it's not case study A, right? What case study? Anyone remember? E. Okay, case study E. Okay, so I'm going to skip them. I'm going to cover A until J, except for E lah, because E already covered. So let's go to look at the problem for each case study. So for you to get an idea how to answer this type of question later in the final exam. Okay, so for case study A is that a chili processing company needs a chili sorting machine. Okay, the raw material consisting of mixed dried chili of various quality need to be sorted before being sold. Okay, the figure below shows an example of mixed chili and salted chili. So this one is, as you know, most of the time is when you have a production line is that you have lots of raw material coming in. Okay, it doesn't matter if it's good or bad. So it's all combined. So raw material is going in into the conveyor belt. Okay, over there, and then you're going to need to sort. Okay, sorry, the company. Okay, or the manufacturing process need to be filtering which chili is accepted, okay, to be sold and which chili is being rejected, okay. So the process had the following requirement specification. Sorting system could process 1 kilogram of chili in a minute. So basically, based on this 1 kilogram of chili in a minute, so think about what type of sensor, okay, if I open this, okay, what type of sensor do you are required? Okay, what type of signal conditioning? What type of data presentation? Okay, and then if you look at this example, is that it's similar like an ability detecting a car lah, detecting an object obstacle. So it's going to detect images. Okay, and that images is that it's going to detect the color. The color. So you might want to convert it to grayscale and so on. So you want to actually sorting it depending on the color coded. And it's going to you're going to filter out the red color chili, okay, and low quality chili or even are being filtered out. Okay, so imagine that you have a raw material coming in. Okay, so how do you sort the material of the dried chili and raw chili? Okay, what type of actuator are required? Okay, of course you need to have a conveyor belt going in. So conveyor belt, basically you can use electrical actuator plus mechanism. So it's going to bring out the conveyor belt. Okay, and then the camera will detect the chilies. Okay, and then how are the chilies are going to be sorted out later on. So might be that the dried chilies, the rotten chilies and the good chilies are differentiated by weight. Example, okay, by weight. So you might actually propose different things. So to answer this, you need to do some research. Basically, before answering this assignment lah, do some research, okay, on how chili is being sorted. Okay, so this one is on the first case study, and there are some students who actually ask, example, if you have more than one actuation system, so how do you draw the block diagram? Okay, as you know, when we talk about control system, to when we draw a block diagram of a control system, one closed loop system represent one reference to be controlled. So if you have more than two systems that you are controlling in this case study, so you need to draw two block diagram. Okay, so but with the different references, so it's going to be have a multiple input, multiple output lah, basically. So this one I have mentioned in the chapter, I think chapter 1 in the first class, where we have the MIMO, multiple input and multiple output. Okay, that one is case study A. Okay, case study B. Okay, a company need a system that can transfer product from point A to B inside a factory as shown in figure below. Okay, point A to point B. The process has following requirement and specification. The system between point A to B is 5 meter. Okay, so reason why it's given 5 meter is that you need to determine whether or not what type of mechanism you want to use. Because as you know, I have mentioned that when you want to convert from rotary to linear, you might think about gear system. You want to use belt drive, or you want to use chain drive system based on distance. Okay, so if the distance is small, then you use gearing system. If the distance is large, then you want to use a belt drive or chain drive. So it depends on a reason why you want to use either one of the system, and why you use chain drive compared to the belt drive. So I have already explained in the chapter mechanism last time. The transfer happens continuously with 5 products in a second. So basically, 5 products will go through the conveyor belt. 5 products, it detect. So basically, you need a sensor to detect 5 products going in. So 1, 2, 3, 4, 5. A counter lah basically. So what sensor do you need? Okay. At point B, the system need to detect the arrival of the product and push them into the box. So at point B here, it's going to collect all the 5 boxes. Okay. And after that, an actuator will be pushing that 5 box into a larger box here. So this 5 box is going to go into this larger box. Okay, the size of product is 0. This is the size given and the product weight is 0.5. So basically, you might want to add. Reason why they give this specification is that, okay, size and also the weight. The weight is due to means that you need to have a sensor. Okay, the sensor is there to weigh the item if it's about the same rate. So when they do packaging, they don't actually count the number of grain inside that box. Example, they are going to weight it 100 gram, 200 gram, and so on. So when they weight everything, then they can actually estimate that the weight is good for one box. So based on that, you will need to determine what type of actuator. Do you think you need 2 actuators inside this case study? And for the control system, what are the things that you need to control? Okay, what do you think that is needed to be controlled here? Anyone? Anyone have answer? What do you think that is needed to be controlled? Pardon? Apa? Wait. Control mesin dia. So what is it? Speed. Need to be specific. Okay. So what do you want to control? Okay. You have learned in actuator. Normally, what do you want to control? You can control temperature. You can control speed. You can control distance. You can control force or weight, like Chu said here. So lots of things that you can think of. For this case study, only come up with one item to be controlled. At least the main thing lah to be controlled. So what do you want to control? Based on the specification given here, I would say that the thing that you need to control is the what? The weight, the product weight is 0.5 kilogram. So you need to have a force sensor. Of course, to control that, the force sensor is important at the end here. But this is one answer. Okay, another student can actually answer differently. Okay, so another student might say that, oh, the one that I need to control is the number of product going into the box here. Okay, 5. You want to have 5 items going in. So you have a sensor, a counter to actually count. Okay, reference there is the reference that you set is 5. So it's going to count 1. Oh, not yet. 2. Block diagram. Not yet. 3. 4. 5. Oh, okay, 5. 5 minus 5, the reference is 0. So it stopped. Then it goes to the next process. So this one is another student might answer like that. So it depends on you. All of your answer, okay, if student opt for the first or the second option, then the answer from task 1, 2, 3, 4, 5 should be aligned. You cannot answer 1 is different thing, 2 is different thing, suddenly jump out to, oh, the one that need to be controlled is the weight. But in the beginning that you say that the one that need to be controlled was the counter, the counting of the box. So I know that somewhere in the middle you discuss with your friends lah. Okay, come up with a different block diagram and it's not aligned from answer number 1 until 5. Okay, so this one is on case study 2. Case study C. Okay. Okay, a hospital need an automation trolley system to deliver foods to patient in infectious disease ward. Okay, so this example, you have a ward here. This is during COVID lah, example. So you have a ward, bed patient. Okay, and garisan line tu means that on the floor, this is what I asked. Actually, student need to ask me lah. What does it mean by line or garisan? But nobody asked me, so maybe they understood the question lah. Okay, garisan or line is basically the line on the floor. Okay, you know the line following robot. Okay, so basically the trolley is a line following robot. You add a sensor on the trolley. And I think I given the student previously in, I think, chapter 1, before there was an assignment where I give to student a video of a line following orbit done by my final year project student. So I asked student where you should put the sensor. Okay, sensor. And how many sensors are required for that system. So for line following robot, at least the minimum sensor that you need is 3. Okay, 3. To detect center, to detect left and right. So 3 sensor. And what type of sensor? Maybe you say that, oh, IR sensor. Oh, I think I need laser sensor or so on. So you need to come up with the answer. Okay. So the specification is that the trolley move forward by following a line of the floor from outside to the ward to each of the patient bed in the ward. Okay, so basically what I explained just now. The trolley maximum speed is 1 millimeter per second. So basically, you already have your answer here, what it needs to control. You need to control the speed at 1 meter per second. So any value given in the assignment like this, specification, so that one is something that you need to control. Like example, before is the weight, so that one is thing that you need to control, or the count the number of boxes, 5. So that is something that you can control. Okay, so based on that, when you have something to be controlled, then you need to have the sensor, measurement system. You need to have the actuation system. Trolley need to be closed within a arm reach to patient to allow them to pick up. So basically, this is where you need to design the trolley at the length of the bed. Okay, so means that they are lying on the bed, so they can just reach out to the trolley and get their food. Okay, so put yourself at the situation where you're lying on the bed. Okay, imagine yourself lying on the bed, and then you need to just reach it out. So what is the length, the height of the trolley and so on. So that one will be more on the sketch. Sketch the concept of your design by integrating all the components. So when you draw out this number 4, I would suggest that draw out the overall view. Overall view not only on the system, but also on the bed. Draw out the bed, side view side view or top view, the bed. And on the right side or the left side is the trolley. And what is the length and so on. Where is the sensor location. And because you need to actually incorporate the sensor to the line following. Okay, so you need to add a line following on the floor. And also the member robot location. Okay, all the sensors. So this is how you need to develop, okay, the sketch. Okay, a motor company would like to produce an electric scooter as shown in figure below. Okay, the scooter has the following requirement and specification. So basically, a scooter is like a bicycle, but you have a motor, electrical motor on it. Okay, so you want to add a maximum speed of 30 km per hour. So that one is the thing that you control. Okay, so when you have that, then you know that you need to follow through lah. So you need to have an actuator, you need to have a sensor, and blah 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 and so on, because you need to control speed at 30 km per hour. Okay, have speed display. So basically, like a motorbike, you have a speed display. What is the current speed? Speed control using speed throttle. Okay. So speed control, you need to go through what are speed throttle, how does it convert to the speed. So is it using gearing system or is it, okay, you need to go through the actuation system. And for this, Okay. It doesn't say mechanism, but well, when you talk about bicycle, when you convert to electric motor, of course you need to have a driving system. So driving system, it can be a gearing system, it can be a chi- drive chain system, or you have a belting system. So which one? Okay, so come up with that solution. And for cases like this, even though the answer is online, maybe you find it, Google it, oh, electrical scooter, blah, blah, blah. Okay, and then you copy paste directly from online, don't do that. Okay, I will know student copy paste online when the answer is very good, means that this looks like copying from something, So I would prefer student to come up with their own answer, a unique answer, as long as it makes sense to the specification. Okay, case study E done. Okay, case study F. Okay, a client A, Fire Accident Berhad, requests this company to develop an autonomous fire extinguisher robot that detect heat from fire, move towards the heat source and start beeping once it reaches the source of the radiation shown in figure below. So, the requirement is that it detects a heat source and its location, control speed and direction of the motor. Okay, so basically you want to have a controller for the speed, detect collision, so you have to have a sensor to detect obstacle, able to climb on rough terrain and slope. So this is where when you're able to climb on rough terrain and slope is that you need to embed a mechanism so that if you see this example is that it cannot actually climb on rough terrain. So how do you convert it to actually climb on rough terrain and slope? Okay, you might need to have a mechanism in this design. So think about how you can incorporate that mechanism. Okay, you might use a 4-bar link. Example, when I was teaching the mechanism topic, remember that I showed to you the 4-bar link cages where the engineer designed the mechanism using 4-bar link, using wind power. Okay, so it's going to move accordingly using the energy of the wind. Okay, case study G. Okay, this one I think I already mentioned before this. So it's on a rehabilitation clinic request the company to develop a wearable automatic lower limb rehab system below lower below waist. Okay, for stroke patient. So basically for stroke patient, they need to immediately do a rehab. Okay, so what you need to do is that to design. Sorry. Okay, what you need to do is that you need to design a mechanism whereby when the patient put the foot on the pedal here, the mechanism will automatically help the patient to do the rehab. Okay, so this the below part is the specification. So you want it to bend at maximum 90 degree, and it basically mentioned here that you need to use a mechanism that able to convert from linear to rotary motion. So basically when you talk like this means that you are compulsory to use a linear actuator. Okay, and you need to use a mechanism to convert from linear to rotary. Okay, it has a specific requirement over here. So your answer need to have that this solution. Okay, and for the closed loop, it mentioned that you need to control the speed at 0.15 meter per second. Okay, for the extension motion and 0.110 meter per second for retraction motion. So different value for different speed. Full load is 20 kg, means that depending on the lower part because the patient is sitting, so half of the body weight is actually covered by the seat, so it's only covering for the leg part only for 20 kilogram. Okay, case study H. Okay, irrigation system is one of the important process in agriculture. whereby is the process of applying control amount of water to plant at needed interval during drought, and automatic irrigation system will be able to maintain the growth of agriculture crop, maintain landscape and vegetation. Figure show example of conventional irrigation system, which is done manually. Okay, so what you need to do is that, okay, specifications that says certain power supply. Okay, the system able to detect the humidity and temperature. Okay, so maybe you were thinking about, oh, okay, self-certain, maybe I need to use a wind power. Okay, wind power, how you are going to convert that wind power to electrical? So maybe you are going to use electrical motor. Okay, electrical generator, sorry, to convert from energy for wind power to electrical. Or you want to use a mechanism to actually convert from the rotation of the wind power to the electricity. So how does it look like, the connection? Okay, system able to detect humidity and temperature, so you need to have a sensor there. Water will be automatically dispensed by respect to the selected sensor. So when it detects that less humidity, then it's going to dispense the water. Okay, so and the water tank its capacity is up to 1000 liter. So you might want to think about what type of actuator going to dispense the water, okay, to the crops. Okay, so I would say that in this case is that you're mostly going to use the hydraulic actuator, okay, to actually use compressed water, and later is going to be used for the crops. Case study I. Okay, so this one is interesting. Okay, it's about a robotic fish. So an oscillating fin, which is an application of a fish fin to propulsion device, is the most important technology for creating a new maneuvering system for marine vehicle. Remember last time I showed to you one of the Festo robot using pneumatic. So they designed the flying robot. Okay, so it's similar concept. How are you going to maneuver the fish in the air, or in this case in the water? Okay, so you're going to develop the underwater vehicle, or we call it as the fish. Okay, so that is going to perform a lifelike fish robot motion. So this is example shown here. You have a tail fin, and then the fin need to flap left and right. So how are you going to flap it left and right? So, and all of these are linked to something, but it's not clear how it's linked. So you are the one designer, engineer who going to design what type of actuator needed, what type of mechanism needed. And the specification is that it need to move forward and backward propulsion. Okay, propulsion tu maksudnya force lah, pergi depan belakang. Able to detect distance and obstacle, so you need to have a sensor, maybe in the front, okay, or at the side. Okay, able to detect depth and water temperature, so because it need to detect depth, then you need to have sensor under the fish. Okay, and the data from the fish can be split at user side for monitoring. So basically, you need to have something like an Arduino to send out the data to the user. Okay, so here you need to decide what type of controller that is need to be controlled. So you might say that, oh, I want to control because it's not specific. So you can select what type of thing that need to be controlled. So if I were you, I would select the speed of the robotic fish for backward and forward motion. Okay, last case study J is on the winding machine, auto winding machine for a 3D printer, 3D printer. So this one shows the machine that is in the sold online, okay, which is about 2,000 ringgit. So actually my student already designed similar thing like this. IDP student, third year student last two batches, they already did this. So this case study is actually a question, is their problem statement for their IDP project, for the year project as a group. Okay, so they design auto winding machine for a spooler, for a 3D printer spooler. And the requirement is that it can adjust the winding speed. So depend on you, you can adjust the winding speed. So this is what you want to control, you want to set as a reference. So you will need to have a sensor to detect spool capacity is complete is full. So once it's full, it need to stop. Okay, if it's not full, it will continue to roll. Stop the worrying process if error. So if there is error, then you need to stop it. So how do you detect the error? So you need to have a sensor, okay, to detect that error. Okay, so based on that, of course, you see here is that you cannot see much, but there is a lot of thing going on here. Okay, the spooler need to rotate, and what is being rotated by? It might be by a motor, okay, an actuator, a motor, and it's linking to a mechanism. Remember, I gave you one example, one problem, a case study lah, on a sewing machine. If you see sewing machine, the the energy is by the human, okay, or by the electrical motor. So you just push on the pedal, and what happens that all of the 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 shaft of the motor is linked to lots of shaft in the sewing machine, and based on that is the sewing machine is going to move. So think of that on how to answer the case study. So you do not need to use lots of actuator in a problem. Okay, you want to actually reduce the actuator, and you can link a lot of the connect all of the shaft using a mechanism so that it's going to move accordingly. So I think that will be all for the discussion on the case study. So I hope that what I have shared this today on the case study is what you have answered, submitted to me for the assignment lah. Okay, assignment is already closed. Okay, so I hope that you did a good job doing the assignment. And what I have shared on the assignment is that for you to prepare for your final exam means that case study can be anything, any problem. Okay, don't expect that the question from assignment is going to go out in the final exam. No, it's not going to go out. It's totally new question. So don't take for granted. Please study for the final exam. And for the final exam, when is your final exam? BEKM 2342? Guys, do you know? February 4. Wait, let me check. February 4, after Chinese New Year kan? February 4, 3 p.m. On Friday. So make sure for the Chinese, make sure that raya-raya jugalah, but make sure that you study for the exam. Jangan lupa lah. So if you want to celebrate raya Chinese New Year, please study ahead of time, so that you are not overwhelmed too much thing later. Okay, so any question before I close today class? Before I end today class, for the feedback form, I haven't actually linked the feedback to the reflection lesson 13.4. So later, maybe after once I've done that, I will inform in Telegram. Okay, there's a question. Chu, doctor, for the part C in final, if the question mentioned required at least 5 function, but we give 7 and wrong 2, in this case, we still able to get marks. Okay, yeah, you still get marks, but I will propose don't put so many function lah in the final exam, okay, because you simply do not know which one is correct, then you put everything. If it's redundant function, it's not count. Okay, redundant, you are going to give, I'm going to give the same marks for redundant function. So it should be different function. But if you think that the case study is more than 5 function, it requires more than 5 function, then you can put there 7 function. I will only correct the 5 function that is correct. Okay. So, and make sure that when you answer the 5 function, it need to be tally with everything that you answer from the part 1 until part 5 lah. So everything from the initial part, from the flow until the description. How does the system work? Okay. Does that answer the question, Chu? Okay. Anything else? Next week we have, I will try to go through next week is the discussion on our activity in Padlet because some of the Padlet activity I have done discussed. But anyway, uh, based on that, I want to just show to student. Actually, I checked the Padlet activity, but I think not all student actually answer the Padlet. Not all. I think only 2 student. Okay, example. Maybe this week 12 ada. Okay, week 14. If you see here, only 2 student answer it. Week 14, activity 4. 2 student. What happened to the rest? I have 33 student. So what happened to the 32 student? You didn't answer the week 11 activity. Even for this activity, also same. Okay, so please go through again all the weekly activity. Okay, if you haven't uploaded your answer, then please upload it ASAP since next week I'm going to discuss it. Okay, so it's not fair to the student who already uploaded, and those please don't copy the student who uploaded their answer because I know that they uploaded earlier. So please upload your answer to the activity. Okay, especially I'm not sure this week 11 activity. Nobody answer it. I'm not sure why. Okay, so well, do it ASAP. Okay, and complete that. Okay, without you answering, then I cannot do any discussion with student. So I hope that that's clear everything. So make sure that you do the activity in Padlet accordingly, like I mentioned in class. Okay, anything else? If no, then that's all from me. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Bye. Thank you. Bye.